Click the bell icon to get latest videos from Ekeeda.
Hello friends. The next question is to construct a Turing machine to accept the language a to the power n, b to the power 2n. That means a number of a's followed by twice number of b's. We have already designed Turing machine for the language a to the power n, b to the power n. The logic would be similar. First, let us start with the construction of TM itself. I'm taking Q0 as the initial state. I replace A with X and go to the state Q1. Q1 will help me in skipping all A's and Y's. On encountering the first B, I'll go to the next state. Along with that, I'll replace the B with Y. In A to the power n, B to the power n, we used to move left after the first B, but we need to read one more B, so we move right. From Q2, we will take one more B. After that, we'll go to left portion. From Q3, we will skip all the remaining symbols till we reach the left, that means the rightmost X. Now from Q0, if we reach straight away on a Y after the X, we can go to the final state. Before that, we need to skip all Y's. On the blank symbol, we'll go to the final state. Here, Q5 is the final state. Having defined this machine, now let us see the components of it and let us try to run a string on this machine using instantaneous description. A Turing machine M is defined as Q, the set of states, sigma, alphabet, tau, set of tape symbols, delta, transition function, Q naught, initial state, blank symbol, F as the final states. Over here for our machine, Q will contain all the states through Q0 to Q5. Sigma would contain the alphabet. Alphabet is having A and B. Tau would contain A, B along with the blank symbol. Let's now write the transition. Delta of Q0 on A will have a transition to Q1, replacing A with X, moving to the right. Q1 will skip all A's and Y's. On the first B, it will go to the next state, Q2. Replacing the B with Y. From Q2, it will go to the next state, Q3, on the next B. Replacing B with Y and moving left. Q3 will keep on skipping all variables, moving left till we reach the rightmost X. On the rightmost X, it will go to the initial state Q0. Now we need to write the path for the final state. From Q0, if we get a Y, we go to the state Q4, keeping Y as it is and moving right. On Q4, we'll skip all incoming terminal symbols of Y. When we reach the blank symbol, we'll go to the final state. So far, we have defined the components Q, sigma, tau, delta. Q0 we know is the initial state. F will contain the final state. Over here, Q5 is the final state. F will contain Q5. Now let's take a string and try to run on this machine. Let's say the string that we are taking is ABB. We are using instantaneous description notation. Q0 ABB. On Q0, first A will move to Q1 by making A replace with X and moving right. From Q1, on the B, we'll replace B with Y and move right. Along with that, we go to the next state, Q2. From Q2, on B, we go to state Q3 by making B replace with Y. Along with that, move left. Q3 on Y will move left. Q3 on X will go to the initial state Q0. Along with that, it will move to the right. Q0 on Y will go to the state Q4. Along with that, it will move to the right. Again from Q4 on again Y will move to the right, but the state would be Q4 only. We see that A's are replaced with X, B's are replaced with Y, and number of B's are twice number of A's. It is of the form e to the power n b to the power 2n. From Q4 on blank, now I'll go to the final state Q5, moving to the right. As you can see, we have achieved the final state Q5 at the end, and hence this particular string is accepted. In introduction of Turing machine, we have seen that Turing machine could also work as output giving machine. We will see more examples of that as well later. Thank you for watching this video. Stay tuned to Ekeeda and do subscribe.